In this video, I'm going to give you an example of a complicated quadratic approximation, just so that you can get a sense of what's going on. So far we've seen that if you want to approximate this, the quadratic approximation of this is given by this, and the quadratic approximation for this is given by this, and so on. In this video, we're going to look at something complicated like this. Okay, so now we are going to try and find the quadratic approximation for something complicated like this. So when you get given something like this, visualize it as this. You've got one block multiplying with another block here. So going back up here, if you look at this, this is in the form of e to the power of x. So we would use this quadratic approximation here. So we would then use this block here to represent just this block here, and then for this block here, we would then this here is in this form here to the power of r, or r being this thing here. So for this block here, we would use this approximation here. So for us to evaluate this whole thing here, we would use this thing here to represent this. Okay, so that's to represent this, and then we would use this to represent this, and then later on we're going to get this block and multiply it with this block here, and then just simply simplify after that. Okay, so for us to really evaluate this thing here, we are trying to approximate this. Okay, so we are going to visualize as one block multiplying with another block here, but then this block here, we are going to use this to represent that block, and for this block here, we would use this here. Okay, so let's start now. So hang on. So this just looking at this here, this is actually this block here. Okay, and then this block is actually this thing here. Okay, so hang on. So for you to do this here, for you to do this, use this thing up here. Okay, so looking at this here, hang on. Looking at this here, we've got to the power of minus 5x, to the power of minus 5x. So hang on, let me just jot that down. E to the power of minus 5x here. So looking at this here, you can imagine this as, let's just substitute this. Let's just say u equals minus 5x here. So now we've got e to the power of u. That's approximately 1 plus u plus 1 over x. 1 over 2 u squared. And don't forget, u is really so this thing here is really 1 plus that u being minus 5x, and then plus 1 over 2 that bubble there, which is minus 5x here, and then we've got to square it because of this square here. Okay, so the quadratic approximation for this thing here is given by this, and don't forget, this thing here is this thing here. Okay, and then you would use the same process for this block here. So this block here, you would, hang on, for this, bear with me. So for this block here, we would use this thing here. Okay, so r would be this here. Okay, so for this block here, we would use 1. So that's this one here, and then r here, which is this thing here. So that would be 3 over 8, and then times x. So that's this x here. So that would be x here, and then plus get r. Here we're just going to factor out the half here. So that's this half here. Okay, so visualize it as this half here. Okay, so that's this half here, and then for the r here, it's just simply 3 over 8. So this is your r here. Okay, and then r minus 1 here would be 3 over 8, take away 8 over 8, that's taking away 1, equals minus 5 over 8 here. So this here is your r, this here is your r minus 1. Okay, so that's this bit here, is this bit here. This r here is this, and then you've got your x squared here, which is given by this. So basically, this block here, that's this whole thing here, times this block here, which is this whole thing here. Okay, so now tidy it up. That will then give you this. Okay, so take your time to tidy this up. So this block here becomes this here, and then this whole thing here becomes this thing here. Okay, so now multiply out the brackets. So when you multiply out the brackets, it's very tedious. So remember, this times this will give you 1. This times this here will give you this. This times this here will give you this. Okay. Now the second part, this times this will give you hang on, yeah. Bear with me. Let's start again. Sorry. This times this will give you this. This times this here will give you this. This times this here will give you this. Now the second part, this times this will give you this. This times this will give you this. This times this will give you this. Okay, and then you've got to do this times this. That will give you this. This times this will give you this. This times this will give you this. And then group all the terms together. So you've got x here. You've got x here. Where else? That's it. So and so on. And then you've got your x squared here. X squared here. Where else? X squared here. So you can combine these three blocks together, and then and so on. Here you've got to the power of 3 here, to the power of 3 here. So you can combine these two together. That will then give you this here. Okay. So simplifying the whole lot here, simplifying everything here, will give you this here. It's very tedious. I've done this for you. But hang on, just watch it through. So here you've got 1, a single number, plus x, and then plus x squared, plus x to the power of 3, plus x to the power of 4. Because we want a quadratic approximation, we want it in the form of a, we want it in a form of, in a way, we want it in the form of a plus bx plus c, c here. This is in the form of, this is a quadratic. You see, this is, well, at the moment you've got one block, you've got another block here, you've got this block here, you've got this block here, and then you've got this here. We want it in a form of a quadratic, so we can ignore, now you can see that it's in a quadratic form now. But the thing is, we can throw away these terms here, or any, if you get x to the power of 7, you can throw away these terms here, because these terms let me think about it. At the moment, you can throw away these terms here, because when you these will be so small and negligible. These terms here, sorry.